안녕하세요 여러분, 해리입니다. In this video, we are going to study series. So in IB series, we have two types in the syllabus. So the first thing is called the Arithmetic Series, and the second thing is called the Geometric Series. So we are going to learn these two. And before we directly go for this, let's just quickly see what series is. So series is just a sequence of numbers with a certain pattern. So the pattern could be increasing by, for example, 1. So for example, 1, 2, 3, 4, 5, that's a series. Or we can also have a series like 1, 2, 4, 8, 16, and so on, where the term is just being multiplied by 2 every time. So arithmetic series is a sequence of number where it has a common difference. So sequence of numbers with a common difference. So for example, 1, 2, 3, 4, 5, and so on. In this case, the common difference is 1 because we see that every term is increasing by 1, right? Or the common difference can be negative as well. So for example, like here, the common difference is negative 1, and here the common difference is 1. Then some important aspects that we can see about arithmetic series is that, so for any series, we have to know the starting point. So the starting point, we call that as the first term. So these examples are too simple, so let's just try a bit. Well, it's still simple, but that one is just too simple. So let's say we have a series like this. Then the first term will be 1, right? So we call this as the first term. And how do we call this? It should be the second term, right? And this should be the third term, and fourth term, and so on. Then let's just see the relationship of each term with the first term. So the second term, which is 2, we start from the first term. Oh, sorry, 3. We start from the first term, and then we add one common difference. So here, the common difference is 2, right? So first term, and then plus common difference. What about for the third term, where it's 5? So we start from the first term, and then we add the common difference, and we get the second term, and then we add the common difference again, right? So first term plus 2 of the common difference. Then if we extend this idea a bit more, so let's do until the fourth term. So we start from the first term, and then we add 3 common differences. So we have this. Then if we extend this to the nth term, then we don't know what that is. So let's just call it as the nth term. Then it should probably be 1 plus n minus 1d, right? Because we see that if for the second term, we added the common difference once. For the third term, we added the common difference twice. Then for the nth term, we add the common difference n minus 1 times, right? So we can derive an equation for the general term of arithmetic sequence. So we can write it like this. So here, oh, this d should be 2, but yeah. So this u1 refers to the first term, and this d is the common difference. So for example, if we want to find the sixth term, then for this case, the first term is 1, and then plus 6 minus 1, which is 5, and the common difference is 2, right? So 5 times 2, 10, and add 1 there, so it's 11. Okay, so this is how we can derive the equation for general term. Alright, so then let's try some examples using this. So let's say the first term is 12 and the 10th term is 3, and let's say we want to find the common difference. Then u10, so the 10th term, should be the first term plus 9d, right? And that should equal 3. And what's the first term? 12. So 12 plus 9d equals to 3. That means 9d equals to negative 9. So d equals to negative 1. And it's very simple. So simple algebra. Second question. So let's say something like this. So we all know how to count the number from when we start from 1. So for example, how many numbers are there from 1 to 1000? Then we have 1000 numbers, right? And how many numbers are there from 1 to 1521? Then 1521 numbers, right? But what if we don't start with 1? So let's say we start with 27 and we want to see how many numbers are there until 105. And for this case, we can apply this formula as well, because we start from here, right? And we stop at here. So for the first term and the last term, or the nth term, we can decide it by ourselves. So we don't know what term is that. We don't know what term that is. So, but let's just say this is the nth term. So to see how many terms are there, and we start with 27. So the common difference here is 1, because we're just simply counting 27, 28, and then so on. So that means we can find it by doing this simple arithmetic. So should be this 79 terms. Okay, so we can quickly see how many numbers are there by using this formula again. Another example is something like, so it's again algebra. So let's say x squared, 2x, and 3 are 3 consecutive terms of arithmetic sequence, and we want to find x. So we don't know the first term, we don't know how many terms are there, and we don't know the common difference, and seems like we can't really apply this. But for this case, rather than just, so don't try to just apply this formula all the time. Just use the general idea of arithmetic sequence. So since these are the terms from arithmetic sequence, that means they should have the common difference, right? And how do we find common difference? We can find the common difference by subtracting 2 consecutive terms, right? And here we have 3 consecutive terms. That means the common difference we could find by subtracting 2x by x squared, and we can also find the common difference by subtracting 3 by 2x. right? And this common difference should be the same, right? So what we can do is that we can equate these two equations so that we will have a quadratic equation. Then we can solve it either by using factorization if you can, but if you can't, then you should probably use the quadratic formula. So we have x equals to 3 and x equals to 1. And let's see whether it really works. So when x equals to 1, it's 1, 2, and 3. So it makes sense, right? It should be the 3 consecutive terms of arithmetic series where the common difference is 1. Then what about when x equals to 3? Then it's 9, 6, and 3. And it also makes sense because this is an arithmetic sequence with a common difference -3. Okay, so this should be very simple to understand. Now what we are going to do is we are going to see a sum of arithmetic sequence. So let's try an example. So let's say we have 1. We have like 1, 2, 3. So an arithmetic sequence with the first term 1 and the common difference 1, and then the last term is 100. And let's say we want to add all these numbers. Then instead of just adding one by one, why don't we add like this, and add like this, and like that? Because addition, the order doesn't really matter, right? So 1 plus 100, that yields 101. 2 plus 99, that's also 101. And 3 plus 98 is also 101. That means we just need to know how many 101 are there, right? Because the results of the first and the last, and the second last and the second last, the second and the second last, third and the third last are all the same, right? So we can easily count how many numbers there are, right? Because we started from 1 and the last number is 100, so there should be 100 terms. And we see that we are pairing these numbers, right? So that means out of 100 numbers, so we pair them up, so we divide by 2. So that means there are 50 pairs, right? But 50 pair of what? 50 pairs of 101. I mean 50 pairs of numbers where the addition equals to 101. So the result must be 5050. And if we write this as in formula, so the notation for sum in our series, we usually write Sn, sum to the nth term, and the formula is given like this. So we can rewrite this a bit by using the formula for the general term. So we know that un equals to u1 plus n minus 1d. So u1 plus n minus 1d, where this is from un. So we will have 2u1 plus n minus 1d. Some may wonder about this way of derivation, because not all the time we will have even number of terms, right? So for example, what if we have odd number terms? So for example, to simplify the case a bit, let's try to use some like less numbers. So let's say we want to add these 7 terms. So using the same idea, we add it like this, we add it like this, and then we have the median, right? Then what can we do with this? So in fact, what we are basically doing is that, so there are 7 terms, right? And if we pair them up, we have 3 pairs, right? But in fact, we have one more number, so it's not really 3 pairs. We can call it as 3.5 pairs. But 3.5 pairs of what? 3.5 pairs of 8. So what we can think this is that instead of thinking that we are actually pairing up, we can just try to think that we are adding 8, 8, 8, and 4, right? But this 4 here, why don't we just try to make it as 8 plus 8 plus 8 plus 8 and divide by 2. Then what that means is that we can factorize it by 8, right? And we can add up by 1 plus 1 plus 1 plus half, right? And what's this? It's 3 plus half, right? So 3 plus half, that means 7 over 2. And where is this 8 from? It's from the addition of the first term and the last term, as what it says from this formula, right? So out of 7 numbers, we divide by 2, we add the first term and we add the last term. So this formula works for odd number of terms, and so both even number of terms and odd number of terms. Okay, so don't worry about that. So we have this equation for sum of arithmetic, and let's try some examples. So in this example, I'm going to tell you a very important property of this SN notation. So as I said, this SN means we're adding from the first term to the nth term, right? So basically the sum of the first nth term. So that means if we have Sn, then we can actually interpret this as the addition of U1, U2, U3, and all the way until UN, right? Then what does it mean by S1? So just recall the definition of Sn. Sn means the sum of the first nth term. Then S1 would simply mean the sum of the first term, right? The sum of the first term, which is just U1, right? Then what about S2? U1 plus U2. So basically we're adding until the second term. This one we're adding until the first term. So since we start from the first term and we end at the first term, then we're basically having U1, right? And it's the same for this. So using these two, what we can do is that if we subtract from S2, if we subtract S2 by S1, then we will have U2, right? And if we expand this a bit, what we have is that if we subtract Sn minus 1 from Sn, then we will have Un, because Sn means Un plus Un minus 1 plus all the way until the first term, right? U1. And we subtract all the way until, so the sum of U1, U2, to all the way until Un minus 1, right? Then we see that they all cancel except for Un, right? So this is how we can find the nth term when we have the sums, okay? Then what's the point of knowing this? Because for some cases, you will not be given with the first term or the common difference or the number of terms. So for example, let's say Sn equals to 2n squared minus 25n, where Sn is the sum of arithmetic series. Then find the first term and the common difference. so this is more clear. So we want to find u1, that means s1, right? And what's s1? We basically replace n as 1. So 2 minus 25, which is negative 23. Then what about the common difference? How do we find the common difference? It's very simple too. So first, in order to find the common difference, so we have u1, right? That means we need u2. How do we find u2? We first find s2. And we can subtract s1 from s2. So minus, so plus 23. So we have negative 19, right? Then what it's saying is that u2 equals to negative 19. Then what's the common difference? Clearly it's 4 because it has increased by 4. So that's how we can find these values, okay? So it's an easy example that we have seen for series, and please be aware that series is probably the easiest topic that you will have for IB. So yeah, you should try to get full mark with questions involving series. Alright, so before we move on, so that's almost the end of that's the end of arithmetic series. So before we move on to geometric series, one thing that I want to tell you, so it's a very rare case that you will have this in IB. So first, it's called the sequence of differences. And what this means is that, so it's similar to arithmetic series, but just the fact that we don't have a common difference. So different differences, so different difference, but there is a certain pattern with difference, and that pattern follows arithmetic series. So which means that if we have a series, then the differences of that series is the arithmetic series. So for example, something like this: 1, 2, 5, 10, 17, and 26, and so on. So we see that it increases by 1, 3, 5, 7, 9, and 1, 3, 5, 7, 9 are arithmetic series, right? I'm pretty sure if you have taken, if you took MYP or IGCSE math, then you have probably seen an example of sequence of differences. So for example, the triangular numbers. Something like this. 15, 15, and something like this. And the reason why they're called the triangular numbers is because we can create a triangle with these numbers like this. So 1, 3, 6, 10, and so on. Then, for example, if we want to find the sum, or if we want to find the general term of the triangular numbers, for example, then how can we do this? So let's investigate this set of numbers. So first term, so this one, the first term, and second term. How do we form a second term? We start with the first term and we add 2, right? So because the difference here is 2, difference is here 3, 4, 5, right? Then what about the third term? So we start from 1, we add 2, which is the first difference, and then we add 3, which is the second difference, right? and the fourth term. So again, we start from the first term, we add the first difference, and we add the second difference, and we add the third difference, and that's how we get the fourth term. Then, if we find for nth term, what can we do? We start from the first term, we add the first difference, second difference, third difference, and probably the fourth difference, and all the way until a certain difference, but we need to find that certain difference, the last difference, so in order to find the value, right? And what will this last difference be? And if you see a pattern, so it's 2 for the second term, it's 3 for the third term, and it's 4 to the fourth term. That means it's n for the nth term, right? So we can always use this pattern to find what we want to know. And how do we add up these numbers? We've already learned it from sum of arithmetic series, because 2, 3, 4, 5 all the way to n is certainly an example of arithmetic series, right? So what we can do is that basically we just need to add from 1 to n. So that's how do we do that? So the first term is 1, the last term is n, right? And then how many numbers are there? We have n terms, right? Because we start from 1 and we have n. So this is what we will have for the nth term of this triangular numbers. And I'm pretty sure if you have taken IGCSE, I'm not really sure about MYP, but yeah, certainly for IGCSE students, this formula is in your textbook, but I remember that they don't talk about the derivation. So this is how you derive the general term for triangular numbers, okay? And using this idea, we can find for something else more later. So, okay, it's a bit short to finish. So, but I haven't prepared the examples for geometric series yet. So I'll end the video right here, and in the next video I'll talk about the geometric series, and also the notation for sum, so sigma, and its basic properties. Okay, so that's it for this video. So it's a very easy thing, so you should be fine with this. So bye.